Here we are at lesson 3 of unit 1. This is about adding and subtracting mixed numbers. So you'll recall in the last video we went over adding and subtracting fractions. Now we're just going to add one layer of complexity to it. We're going to be adding the idea that there are mixed numbers and improper fractions, as well as what we call a proper fraction. Okay, so let's look at some of this terminology right now. First off, we're going to look at a mixed number. And a mixed number is a combination of a whole number and a proper fraction. So 1 and 1 over 2 is a mixed number, okay, because it has a whole number, which is, okay, that's our whole number, and that's our proper fraction. Okay. Now, a proper fraction always has a numerator that's smaller than the denominator, like 1 over 2. 1 is smaller than 2. 11 over 15. 3 over 6. 7 over 8. They're all proper fractions. Okay? So a mixed number is basically just a whole number and a proper fraction. So we could have some other examples, 3 and 16 over 17. It's a mixed number. Okay, so let's look at the next thing, which is an improper fraction. So now remember we said that a proper fraction has the numerator smaller than the denominator. And for an improper fraction, the numerator is larger than the denominator. Okay, so we've got the numerator is larger than the denominator. Okay, and that's important to keep in mind. So for example, 3 over 2 is an improper fraction. Okay, now in the world of mathematics, improper fractions are really useful. Improper fractions are what you're going to use when you're doing actual calculations. Mixed numbers are more helpful when you're trying to translate that improper fraction into something meaningful. So for example, if I read 3/2 of a book this weekend, if I said that, you'd look at me like I was losing my mind. You'd say, 3/2 of a book? What are you talking about? But if I say I read 1.5 books, you go, oh, well, that makes perfect sense. So mixed numbers have much more meaning when translating answers into ideas, into statements, into kind of a real world thing than a mixed number, than an improper fraction does. An improper fraction, while more useful from a calculation standpoint, is less meaningful when you're trying to interpret your answers. So throughout this course, we're going to use both. We're going to use both improper fractions and mixed numbers, and we have to be able to switch easily between the two of them. Okay, so when you're adding and subtracting, you should convert to improper fractions. Then add and subtract like normal. Okay, so we're just going to add one step to the beginning, and then we're going to do everything we did in the last video. So let's practice converting. Okay, so the very first thing we need to do is practice converting from a mixed number to an improper fraction. Okay, so what we're going to look at is we're going to say, I have to take this whole number, and I have to make it into a fraction with the same denominator. So 1 is the same as 4 over 4. Okay, so if I have 4/4, I have one whole number. So what I actually have here is 4 over 4 plus 3 over 4, which is going to be 7 over 4. All right? The interesting thing is there's a shortcut. All right? There's a shortcut that lets you do that really easily and really quickly. So you can do 1 and 3 over 4. You can go 1 times 4 plus 3. Okay. 1 times 4 is 4. 4 plus 3 is 7 over 4. See how that works? So that's the shortcut. But what you're actually doing is transforming the mixed number into a fraction with the same denominator, and then just adding it to the fraction you have already. Okay, so let's look at the next one. I'll show you both ways of doing it. So first, if I want to make 3 into a fraction with the denominator 11, I'm going to take that 3 and, okay, so 1 is the same as 11 over 11. So 3 is going to equal 33 over 11, right? 11 over 11 plus 11 over 11 plus 11 over 11 makes 33 over 11. You can also check that by dividing 33 by 11, and you should get 3 as your answer. So I'm going to have 33 over 11 plus 7 over 11, and that's going to give me 40 over 11. Or, dun 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 dun, we do the quick method, and we say 3 and 7 over 11. I'm going to get my red pen. 3 times 11 is 33. 33 plus 7 is 40 over 11. And now I've converted. Okay, so we're going to do some quick adding and subtracting. So let's go through this. 2 times 3 plus 2. 2 times 3 is 6. 6 plus 2 is 8 over 3. 1 and 1 over 2 is 3 over 2. Now I need my common denominator. It's going to be 6. Okay. So I multiplied this by 2. That by 2 is going to give me 16. This is by 3. This is by 3. That's going to give me 9. The 16 plus 9 is 25 over 6. Now, 25 over 6, can I switch that back? I can. I'm going to say how many 6's go into 25? So 6, 12, 18, 24. So that's going to be the same as 4 6's. And between 24 and 25, I have 1 left over. So I'm going to have 1 over 6 left over. I'm going to 4 and 1 over 6. So let's do one more quick example. 3 times 4 plus 3. 3 times 4 is 12. 12 plus 3 is 15 over 4. 1 times 6 is 6. 6 plus 5 is 11 over 6. I need to get my common denominator. Ooh, switch colors too quickly. My common denominator here is going to be 12. 4 times 3 is 12. 15 times 3 is 45. Okay. 6 times 2 is 12. 11 times 2 is 22. And 45 minus 22 is 23 over 12. I want to switch that back. How many 12s can I get into 23? Well, 2 12s is 24, and I can't fit 24 into 23, so I'm only going to be able to get 1 12 out of there. And then I'm going to have 11 12ths left, because 23 minus 12, because I only took 1 12 out, 23 minus 12 is 11. Okay, so here's some important information. It says convert back to a mixed number at the end if the question is a word problem, or if the question says express all answers as mixed numbers if possible. Just to let you know, that phrase will be on every test that you write. So keep an eye out for it and make sure you're comfortable switching both from mixed to improper and from improper back to mixed.